Hey everybody, this is Mr. Walsh, and today we're going to look at the answer key to the Lewis symbols worksheet. Okay, so you probably need a periodic table. We've been adding to this all through the year, so we'll keep going now. Okay, so calcium. What we're going to do is we're going to fill out all of these, and then it's actually going to be pretty straightforward once we get into this. Okay, so calcium. When we're looking for the number of valence electrons, we are looking at the group number, okay, not the charge, okay, but the group number. So that's going to be group number, or that's going to be number 2, okay. And so the symbol of this, we put a CA, we put 2 dots. The way that I do it is I start at the top and then I go around. I'm going to go around once, okay. For the valence shell, it is the period number 4. Or if you do the Lewis, if you do the electron configuration, right? You have argon 4s2. It's the biggest big number, so it's 4. But we'll just keep it. We'll do it by looking at the period number. Okay, and then the group number of calcium is 2. We already looked at it. And now we're looking at the likely charge. So is calcium more likely to lose 2 or to gain 6? It's definitely more likely to lose 2. Sorry for my voice cracking there. So when it loses 2, that means it's going to become a 2 plus charge. Okay. So carbon. Okay. Carbon has 4 valence electrons. We look at the periodic table, you can find that out. So again, we're going to go 1, 2, 3, 4. 1 dot on each side going around. Okay. Carbon is in the, its valence shell is 2 because it's in the second period. And its group number here is now 14. Notice there's a difference between the valence electrons and the group number. You only use the one spot to determine the group number. Okay. And this is, this could either lose or gain 4, because there's no difference between losing and gaining 4. So we'll use we'll use context clues when the case arises with carbon to see whether it's losing or gaining 4. So this could either be a plus or a minus 4. Okay. And then hydrogen, number of valence electrons is 1. Lewis symbol, so we're going to put H. We're going to put 1 dot around it. Its valence shell is 1. Its group number is 1, and then in this case, it wants to gain 1 to look like helium. So if it's going to gain 1, it's going to become a 1 minus charge. Okay. So now we can do this a little bit more. So phosphorus has 5 valence electrons. So phosphorus 1, 2, 3, 4, 5. We put the dots in here. Start at the top and work our way around. It's valence shell. Phosphorus is in the 3rd period. Group number is 15, and it either could lose 5 or gain 3. So it's going to be more likely to gain 3 just by sheer numbers. So this is going to be a 3 minus charge. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay. Its valence shell is 2, group number 16, and it's more likely to gain 2 than it is to lose 6, so that's going to be a 2 minus charge. Fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay. Its valence shell again is 2. Its group number is 17, and this is going to gain 1 electron, so it's going to be a 1 minus charge. Neon, let's see, we have just a couple more to do. Neon has 8 valence electrons, so we'll do Ne, we'll do 1, 2, 3, 4, 5, 6, 7, 8. Okay. Its valence shell is 2, its group number is 18, and this is not going to do anything. So, none. There's no likely charge on this. It already has 8. It already has its octet rule satisfied. Sodium has one valence electron, so we'll do Na and we'll put our one valence electron there. Its valence shell is 3, its group number is 1, and it's either going to lose 1 or gain 7, so it's more likely to lose 1 electron, so that's going to be a 1 plus. And then aluminum has 3 valence electrons. We'll do Al, we'll do 1, 2, 3. Okay. I don't know why I went over here. That's not an electron. Okay. And then its valence shell is 3. Its group number is 13, and it's likely to lose 3 electrons, so it becomes a 3 plus. Okay. So now in the back, question 2 says, what's the relationship between the group number and the valence electrons? So technically, the group number is one's place of the group number is the number of the valence. Not of the number of valence electrons. Okay. So if we had, let's see, group valence electrons. So if we had group 1, it would be 1 valence electron. But if we had group 14, the 1's place is 4, so it's 4 valence electrons. Okay. And so now to reinforce this, we go down through and we see this. How many valence electrons do the elements have in each group? So group 1 is 1, group 2 is 2, group 3. I even say that this is group 3-teen, not 13, to kind of reinforce that as 3 valence electrons. Group 14, and I say group 5-teen, 15, say 6, 16, 17 is 7. Group 18 now. And group 18, most of these elements have 8, right? But one element, helium, or if you just put He there, that's fine, only has, and we'll look at helium. Helium's all the way up here. Remember, because it's in the first period, or the first energy level, helium's electrons, there's 2 is as many as it can have. That completes its valence. So helium only has 2 valence electrons. Okay, so there you have it. That's the Lewis symbol worksheet. Okay, everybody, have a great day.